All right, hello everyone, and welcome back to the final LiveCTF stream for this DEF CON qualifiers. I'm here with Josh and Mark.
Hello, I'm Josh.
And yeah, we are going to look at the last challenge that we just wrapped up, and then we're just also going to talk a little bit about the whole event as a whole. So over the past 4 hours, we had this challenge called No F in the Stack. That was written by Glenn. Unfortunately, we had to make a little bit of a challenge swap. Josh had created a challenge, which actually I would say is probably my favorite, except it didn't quite work.
Oh,
Uh,
well, it's nothing's perfect. Words,
yeah.
Details.
yeah,
Yeah. Although I have high confidence that we can get that one back for the finals. So we're not gonna talk about that one because people might have to endure it in August. Let's before we go into the challenge, let's just have a quick look at the scoreboard. I'm gonna refresh this, and we have Super Dice Code are now in the lead. MMM demoted to second place. We've seen MMM like bouncing up and down here at the top, and then have a bunch of other teams. I think Null was up there in a while. Hype Boy climbing back. They started out really strong, kind of fell off, and now they've come back into the top as well. So
Macaroni was at number 8 the last time when I went to
oh
bed.
wow,
oh yeah. They were really like for the longest time they were really hovering around here. Like I think they were down at like 11. They were up to 8. They were really around this like the qualification threshold. So now they've bought themselves a decent amount of leeway here, which is cool to see. And I think they have been very active in the live CTF challenges. I think I've seen them solve every one of them.
And
I'm pretty
quickly too.
sure. Uh-huh.
yeah.
Yeah.
How many points would that add up to? That would bump them up a couple positions, right?
So if you are the first solver on every live CTF challenge, you get 300 points.
Okay, so that'd move
Uh,
up a position.
yeah. But on like, of course, the other teams, they will probably also solve the challenge. So I wouldn't think that like live CTF gives you like 300 points ahead of the pack, but like, maybe you can add maybe 100 points to your lead or something if you're performing well in
Yeah.
live CTF. But yeah, so the challenge we are gonna look at No F in the Stack was written by Glenn, who I think is a bit too tired to be on the stream for now. He was up late, but basically it's a see if I don't have the code here, but basically it's a fairly straightforward uh, stack buffer overflow challenge. So you can write data to the stack and write a ROP chain, although there's like this little twist to it, which is that the values that you write can, like the hex representation of your values cannot contain like the hex digits A to F. So this puts restriction on what gadgets or like what addresses you can put in your ROP chain. You can also not have the value 0 because that's kind of the thing that terminates the loop that reads in values, which was actually an issue for me when I was solving this because I wanted to do a read syscall, which requires
Oh no.
RAX to be 0. So I had to do a very convoluted thing to accomplish that. But we got, let's take a final look at the solve count for that one. We did get 26 solves, which I believe is the highest number among our challenges for this year. I think Wrapup had 24, if I remember correctly. Yeah. So this was the most solved live CTF challenge, and not that surprising, I would say. It's a fairly vanilla challenge with this like one constraint, which, you know, with a little bit of work, you can work around it. We had the first solve at about 30 minutes in by Null. So maybe we start by looking at their solution actually. And I'm gonna increase the font size here a little bit to make it easier for everyone to see.
Oh, that's a short
Yeah.
chain.
Yeah. This is, yeah, very short. And sorry, Mark.
A few teams have been really good about having concise solutions, which I appreciate having to read them really quickly to figure out what they did. But
Yeah.
obviously, readability gets you no points. Speed does.
Yeah. So actually, what we could do is, if I, for a second, switch away from my screen share, what I'm gonna do is I'm
We're
actually
seeing your
gonna.
terminal.
Yes, but the viewers are not,
Okay.
because I switched away from that scene and in OBS, so that's all good. What I'm gonna do is that I'm actually gonna open up the binary in Binary Ninja, so we can just jump to those some of those addresses and quickly confirm what we are looking at. A lot of the teams have been nice enough to comment what their gadgets are. We appreciate that, but I think it would be fun to see here as well what's going on
Yeah,
here.
I think this team, their solution involved what, like less than a dozen gadgets. So I think they were just making it, you know, step through in GDB, see what your state is like, figure out what you need to do next. Okay, cool. Found the next thing, rinse and repeat.
Yeah.
Now, what I am interested in seeing is I think I saw zeros in their solution.
Yeah, let's have a look at that. As soon as I have typed tar and open the challenge and it's disassembling. Okay, we're gonna swap back here to my thing, and yeah, so no,
oh
we
no,
have
okay.
a
Yeah, there's a zero
the
to
zero
terminate.
is, this is the zero to terminate. Yeah.
Got it. Okay,
And
the ones were kind of throwing me off, but I think they found like a deck Rax or something.
right. So the I think what it is no. So this is basically the to start the overflow. So basically, the way it works is that you have a very small array on the stack, this one, and then there is an index variable. But the way it's laid out in memory, the index variable is after the array. So if you would just write, for example, ones all the way, you would, like, the index variable increases, you would overwrite with a 1 and it would jump back and restart at index 1. So what you have to do is that this is basically, this 4 here is the 32-bit. So these are written as 64-bit values. So this upper half of this 64-bit value is like the index variable into the array. So this is just like dummy value, dummy value, dummy value, and then you overwrite the index variable with, in this case, 4. So basically we stay at the same place, and then the index keeps incrementing, and you can just write whatever. So this is kind of, this we will see in basically every solution to kind of kick off the overflow. Yeah.
So the fact that the addresses are decimal in the solution script makes me think that they just opened it in GDB and like grepped for gadgets. Because I don't know any other tool that actually. Oh, fun fact: Binary Ninja, you can just prefix with 0n to get a decimal.
Oh, nice. I also realized that I actually should not be doing that, because it's like they are decimal, but I should treat them as hex
Oh,
values.
does it
So
read as
basically,
hex? Oh, it reads hex.
yeah. So here,
Okay.
yeah. So this is a system. This is a return to system. So basically, I assume that one of these, probably like this one or this one, is going to be the address of the. That's one of these is going to be the the string, right? Maybe.
Maybe.
Uh,
Oh, none. I'll tell you what. None of these are.
yeah, this probably aren't remapped.
No, this is.
Or the two
But this
ones,
one,
sorry.
these are, but
I mean, that
I don't know.
250289 could be loading a temporary value into register, and then the gadget next, like, actually modifies it into something that can be used. Because, like, we're at a add RDI rack, so we're not going to see like a OX like 5B or whatever.
Yeah, interesting. Okay, but basically, we have a pretty like they are setting up the they're setting up the reference to the bin sh string, and then they're jumping the system. I assume that this is what's happening here, basically. And this is a very common theme. Like if we look across the solutions, I took a kind of scan through these, and my general impression is, for example, here is from Zero Rocket Rex. So they have some pop RDI, I believe this gadget is, and I
Probably
guess
just
it's
using
on.
as a scratch register, or
No, but I think this is unaligned, so this will not show correctly in Binja. So they are because they are jumping to the 18 address here. So you will get the you jump to unaligned instructions to get the other pop. But yeah, if we look in here, we see pop RDI and a system gadget. So this is also a similar approach. You know, get the string, go to system. We're done. This is another one of those where it's like, you know, we just dump the values in a string and we send it. I guess this is gonna be this. Yeah, so I think we're gonna be very familiar with this 1917 address here. Which this one is a little bit longer though. So yeah.
Yeah, it seems like some teams just found slightly more optimized gadgets.
Mm-hmm.
You know, maybe skipping over an exchange or skipping over some weird bit mask that you're forced to work around.
Yeah, and looking here, yeah. So here I think we have another idea, slight variation basically, where we're doing a syscall directly instead. So I think the general theme here is that the kind of like two main branches, two main approaches. One is to use the system function that's already in the statically linked binary, and the other one is to do a like set up an execv syscall. That seems to be kind of like the two main approaches that we're seeing. So although in the end here, maybe they actually didn't use this, because at the end of this one, we see this 1917
system,
address. Yeah. So maybe, you know, this is like work in progress stuff. They were thinking about, okay, we do, you know, like you just go through and gather some useful gadgets, and then they realize that actually we can just jump to system here.
Yeah. And you said the first solve for this challenge was 33 minutes in. It looks like between 30 minutes to an hour, there were 3 solves. So pretty consistent timing on first solves. Then at the hour mark, there was a jump, you know, 6 solves in the next 15 minutes, and then.
Yeah.
So it seems
like a
like
whole
people
batch
just,
of them.
you know, you can only be so much faster looking for gadgets when you're building a chain that's a dozen or so gadgets long. Well, this one's a little longer, so.
Yes. So what is happening here is for RBX calls.
Oh, that's just the 1917. So that's just the system call. I think they just have the 4 RBX commented out.
Yeah, but why are they doing?
Oh, that's so early.
Because they have it down here as well, and they have, so they here it looks like they're setting up some value in ESI, and they're adding it to EDI like a couple of times. Interesting. Pop.
They're not setting
Specifically,
up a
they're popping this 10, and they're adding 10 6 times, so they're adding 60 to. Yeah, It looks like they're.
Oh, you know what? They might have found the address of BinSH and then
Oh
have
yeah.
to offset because it has like a
Yeah. That's so. If we search for the string here,
yeah,
we
there's
see that it's and this would make sense that if, let's say, so here they are. So here they pop RDI, they set RDI to this value. So you see like 490, 499.
yeah, that'll do it.
Then they get RSI and add it to this, which will flip the 9 to an A. So we're adding this, and then you see we need to add on the second position. We need to increase it from a 9 to an F, and that's why we add 10 6 times here. So that's really nice, actually.
Yeah, I mean that's a totally valid solution. I think. Are you given stack leak in this challenge?
No, but it's non-pi.
No,
So it's yeah. So
Okay, so
everything
I guess
is
you
at
could leak it later, but
yeah.
okay. Yeah, I mean this seems like just a good solution. Like it seems like they thought of just call system with BinSH early and then spent their entire solution building up a pointer to BinSH.
Yeah, I want to know what this is though. Because
that's unmapped.
It's very early.
400, 900. I think that's just because that's the initial value they're popping in, right?
No, but what would that be? That would be unmapped or uninitialized. Because here they are.
Well, yeah, wait, the early system, we never figured that out.
Yeah.
Honestly, maybe that could have just been, well, hang on, pop RBI. Yeah. They just have
could
a
it be
pop
that like
RBP
randomly this memory location maybe contains. Like it could have been that maybe locally when they did this memory address just happened to contain.
No,
like
I mean,
where is it?
That should be deterministic, right? Because as long as they're running with the same LD.
Is it like read-only zeros or something like that? A pointer to a read-only zero?
But then you're calling system with a string to 0 right after.
Yeah, that's interesting.
That's weird.
Yeah, maybe we'll have to run it and look at what's in here. But yeah, a good solution though. Just like you couldn't find that or you couldn't use that address directly, so we do some arithmetic to work around that. Here's another one where this is not 1917, but it's close enough. I think this is probably just at the beginning of the.
Oh, it's just like at a pop. A move.
Oh, they include. It's the it's moving RAX into RDI. Of what?
Oh, originally it's just an empty string.
Weird.
Well, no, because they could populate our racks before. So they build racks. It seems like they're building racks to a benefit.
Oh yeah, of course. I'm stupid. This is just resolved.
Yeah, the annotation confused me. That's why I was like, what is
yeah, exactly. So we have stuff before here which would add.
Why are they sending their last send line is 0 followed by OX dead? Which is weird.
Wait, sorry, where?
At the bottom of their solution there. R.sendLine after, please. So. I think that doesn't matter. I think that's just. But one of their gadgets.
Yeah.
Oh, no.
Or. Yeah.
It's probably just the 0 to terminate, right?
Yes. And because it's using scanf or yeah.
Yeah.
So that one should just terminate here.
Who knows?
Interesting. Or this could end up in some buffer somewhere, which they could, but I don't. Yeah, I don't know. Or just it's just there to. Maybe it was easier when they were debugging to like find this, or I don't know. Actually.
Yeah, it does look like this team did a similar thing with the arithmetic and.
Oh yeah, that also
the
looked.
777s
are
are numerous in this one.
Yeah, here we have. Okay, do we actually have syscall this time? Because if so, I want to look a little bit closer here and see. Yes, so here's a syscall. So what are we doing here? I guess the most interesting thing here is probably like which syscall we're doing. So here they're doing. Oh no, these are gonna be unaligned, right? Oh god. I would have.
Oh yeah, they very much are. So what would that be? 5e41. Anyone a disassembler off the top of their head?
I mean, you could always like.
I mean, in Benji, you could just create a function at that offset, like.
I could also just like. RP++ challenge R3 grep.
What is RP++?
It's a ROP gadget finder.
Oh, okay. I'm still over here using Wrapper and ROP gadget.
Except it didn't work. Okay. Oh, maybe.
Honestly,
sorry.
I'm still using grepper, which is like an RPISec utility that.
Oh, here, yeah.
Developed.
So this is a pop RSI, pop R15, pop RBP. So this one goes into RSI. So that's not the syscall. Could this be the syscall? No.
Oh, so they're just working maybe off No, I don't know.
Let's look at this one. Is sub. Okay. So
they're doing similar arithmetic. I mean, you're gonna have to end up building a pointer to binsh or writing your own binsh string in here, but like you don't have a stack leak, so good luck.
Yeah. So they are subtracting, and then we have.
This was the idea that seems most apparent, right? Is like if you're a little bit limited, then maybe you can find gadgets that have like the bottom byte or byte and nibble that you can just adjust with some arithmetic.
Mm-hmm. Yeah. Oh, sorry, that was the same one. Sub. So they're setting up very. So pop RSI. So we're first getting this address into RSI, and then we're doing a bunch of subtractions, and maybe there was already. Wait, hold on. They're writing.
Wait, what?
That's a lot of. Is this? Oh yeah.
Oh no, they have an anti there.
Add RDI. Okay, so basically.
So they just divided the address of binsh.
Yeah. And then I assume that somewhere here, this is gonna end up being an exec. Like they're gonna.
Yeah,
they're doing this
an exec v, like you're calling syscall at the end.
Yeah. No one did the completely over the top solution like I did when I tested it and did like mprotect and read and read in shell code.
No, I think you overcomplicated a little bit.
Yeah. Okay, that's cool one to see.
Yeah, I'm surprised to see that no one did ret to gets, honestly.
Maybe that was at an inaccessible address, for example.
I mean,
like,
I guess, yeah, there might not be good gadgets to push a modified address. Oh, that would do it.
Is it not? Wait.
Oh, this is statically linked. You don't get a leak. So yeah, gets wouldn't be compiled in.
Uh-huh.
That
Okay.
explains it.
Yeah. Another one with kind of difficult. No, that's the 1914. That's system.
Mid blah.
Pop RDI, RDA. Yeah, so here's another arithmetic thing. We start off with some, get RAX to 7. And then they...
Yeah, they add Rax RDI. Just same thing, adjusting.
Yeah.
The the move RDX down there, was that just a bit mask of the lower lower byte?
Oh, sorry, I closed it.
No worries.
Yeah.
So it seems like teams all had the same solution in mind, essentially.
Here's a
Whether they ended up
simple...
with a system call or, well, a call to system or a syscall, but everything else seemed pretty along the same, train of thought.
Yeah, and it seems like everybody's solution basically was, I'm going to open GDB and just adjust this. Like a lot of copy pasted values.
Yeah,
But I think
it
that it's a
finds
good point,
different
right?
gadgets. Yeah.
This is still a manual process. Like it's not that hard once you understand it, but I just don't see any automation making this easier.
Yeah.
Without being
Yeah.
a lot of work.
Yeah, here they do the same thing, right? They're adding these two values together to get the address, and then they go to system. I think this is like the clearest and most concise. Like we do pop RDI this value, and then we move it into RAX, then we pop it again, and we add them together into RAX, and then we go into
Do they
the
call
system.
their add gadget?
Here.
Okay.
That's
they just don't use the variable.
Yeah, this is
it's very CTF code.
Yeah. Similar idea here.
Yeah.
Addition into system. It's basically the same solution. I think we will see a lot of these. That's a 1914 again. There's some addition. There's some there are a couple of variants on how you perform the arithmetic. But this is.
They have a. Huh. So they might be building the BNSH string themselves?
Yeah, maybe a little bit. Do we see this? SH. Oh, because you don't. It's like SH is in the path, so you actually don't need bin SH if you do system, because then you go via shell.
Yeah.
You only need the full path if you do execv. So here
right.
they just find an S and an H. And they manage to put them together, right?
That's funny. I feel like everyone is so knee jerk. You need to find the full bin SH string.
Yeah. That's cool.
Clever.
I like that variant.
Oh, this one is. Okay, I was like, wait, they got it with one call to 0?
Nah. This one we haven't seen before. Where does this end up? I think is this. Syscall. Okay.
Oh, it's aligned. Was that a Zor SIL81? Yep, that's math.
Oh yeah, because they cannot use the no. It's because they can't use the syscall address directly because it has an A in it.
Oh, so that just does nothing, and then it just goes.
Yeah.
Okay.
Exactly. So that's good. Yeah. I don't know if we don't need to look through all of these.
Yeah.
We see these kind of patterns. Like some do system, some do execv, some provide their own string, some find the string via arithmetic. Yeah, again here. So we have some small variation, but I think it's pretty straightforward. I think it's a nice nice to see this. It's more about how they structure their code, and also a little bit in the choice of gadgets. And some of these are a bit longer, a bit shorter. Yeah. But that's basically the challenge. And as we said, we ended up with 26 solves on that one.
Which you said was the most solved challenge, right?
Yep. With like the bulk of the submissions coming in between like the 1 hour, 1 hour 30 mark there. We had like a big chunk of solutions, and the first solution after just 30 minutes. So yeah, it's really cool, and that kind of wraps it up for us for LiveCTF for this year's qualifiers. There's still almost 12 hours left on the qualifiers as a whole, so we don't know yet who will be qualifying for the finals in Vegas. But
and actually,
we will be there.
just took first place back.
Oh, I should refresh this. And they are back in first place. Yeah, we see Super Dice Code and MMM have kind of like broken away from the pack, like solidifying the lead here. Cool to see. And yeah, I think it's interesting because I mean, of course, it's it's cool to win the qualifiers, right? But the important part of this scoreboard is not what's going on up here. It's what's going on around down here in like 8th, 9th, 10th place. That's where the action is. So, and here it's actually quite tight. We see now the difference between qualifying and not qualifying is currently like 130 points, which is not a lot.
Yeah, look at that group of teams down 10 through 13.
Oh my gosh, yeah, that's within 50 points.
Yeah, so I'm going to look here in my other browser where I can actually see the challenge values, and a lot of the challenges are valued at around 200 points. So, and maybe some of them even a bit more. So like,
I mean, 2 challenges could bring any of those people.
Yeah. Like any of these could just jump up.
And actually, I think MMM already qualified, right?
Yep.
And
yeah. So the cutoff, so we have the on the Nautilus website.
Yeah, so MMM, Friendly Maltese, the team name that I can't pronounce that I think is Swedish, and Wrapup already qualified.
It's
and whoever won CTF,
Kalmar Unionen, and they are Danish.
Danish.
Yeah, they have some Swedish.
It's all the same.
They have some. They have some Swedish players, but they're.
And actually, it looks like Blue Water also qualified.
Yes.
From Plaid CTF.
Yes, but they are down here, so they don't.
Yeah, I was gonna say I'd be surprised if they didn't qualify. They're a really strong team, but they already did.
Yeah. Yeah. Other than that, like I think we're happy with how this went with LiveCTF. It's always fun to do these faster challenges, to see actually get to see the solutions with this setup where we have this submission system. And yeah, I mean, of course, it sometimes creates a little bit of friction for solving, but I think it's it went fairly smooth this year as well, and I'm happy with it. I think the challenges were cool. Went well.
Yeah, there were definitely some unique challenges. I'm surprised that we're still finding ways to write challenges we're excited about and that competitors hopefully like. We'll get feedback after the CTF, but overall, yeah, pretty happy with how this went.
Yeah, now we just need to write a whole stack of challenges for the finals.
It's simple. We just write 15 more challenges. How hard could that be? We have months. We can push it off.
Yeah, it's fine. Yeah, I don't think there's too much to add. We will, as usual, we will be publishing all the challenges, all the solutions from the teams, everything on our GitHub. I think we will update the descriptions for these streams to link to that as well. You can find all of the materials. If you have any questions or comments about the LiveCTF, just reach out. We're happy to hear from you. Yeah, and I think that's basically it. Thanks a lot, Josh and Mark, for hanging out this weekend.
Yeah, thank you for running things and
Yeah.
getting this all to run smoothly as a big part of it.
Yeah.
Yeah, I have some servers to destroy now.
Don't we
sleepy
all?
time for me.
Yeah.
Oh, there he goes.
Nice.
Yeah, so fun fact, Mark actually sleeps the entire time we're not on camera. We actually just call and wake him up for Quals. Not even finals. Finals is a weekend at Bernie situation. It's
yeah. Yeah, so that's it for us for now. You will see us again in August. We will be live streaming from DEF CON in Vegas. We will make announcements on the socials and post links and everything. So until then, yeah, see you next time.
yeah,
See you,
happy
CTF fans.
hacking. Good luck, have fun.
Bye.